Part 2, continuing on with 6.6. Remember, it's all about matching out what is in the same area. So I want to solve for x. So here is 8 plus x, and it lines up with 8. In the same triangle as 8 plus x, we have 27. And what lines up with 27 is 12. This is using the triangle angle bisector proportionality. All right, so to solve this, we use cross multiplication again. So we have 12 times 8 plus x equals 8 times 27. Use your calculator to help you. That's why they're there. All right, coworker wanting to know if I was recording in here. Okay, so we use distributive property from this point here. So we have 12 times 8, which gives us 96 plus 12 times x, which is 12x, equals 8 times 27, which gives us 216. And here's where we do our little variables and constants. So our variable, we have 12x. Our constants, we have 216. We want to move this 96 over, so we turn it opposite. Sorry if I'm moving kind of fast, my bad. Let me slow down. Okay, 216 minus 96 is 120. Now to solve for x, we divide by 12, and we get that x equals 10. So the geometry part of this one, of course, was our setup, this right here in the brown color. The algebra was all of this peach or orange color. I don't know what it looks like to y'all. But let's do another example of using the angle bisector proportionality to be able to solve for x. All right, so here we go. So we have 3x plus 4. And it lines up with, on the other side, we have 20 is equal to, in the same triangle as it, is something we don't know, but we can find it because this entire thing's 18, and this much of it is 8. So we can do, okay, 18 minus 8 gives us 10. And you're like, how do you know how to do that? Well, we've already discussed about segment addition, and that's all that is, okay? And what lines up with 10? Well, that would be 8. So now we're going to solve using cross multiplication again. So we have 8 times 3x plus 4 equals 20 times 10. We're going to use our distributive property. So we have 8 times 3x, which is going to give us 24x, and then 8 times 4, which is 32. Equals 20 times 10, which I do believe is 200. Now let me check my math on all of that I did in my head, just to make sure, again, that I'm not cuckoo for Cocoa Puffs. I am. I do like Cocoa Puffs. They're delicious. I like them better than Cocoa Krispies. I don't know. I just do. Okay. Because that's relevant. Okay, here we go. We have our variables and constants again. So our only variable, we have 24x, and it can stay the same because it's already over there on the variable side. On our constant side, we have a 200 over there. We need to move our 32, so it needs to turn opposite. Okay, so now we're going to do 200 minus 32 gives 168. Now to solve for x, we divide by 24. And we get that x equals 7. And both of these examples that I have done with you, for example 4 for angle bisector proportionality, solving for x, are 2 questions on your homework for Google Form. All right, now, goal number 3, parallel lines and proportionality. This is just like what we did with triangles, but it's all about, again, matching up. So, for instance, if we have this side, it matches up with this side. See, they're right across from each other. If we're dealing with this side, it matches up with this side because they're right across from each other. So pretty much this theorem is telling us that if we have three parallel lines, we know they're parallel because these red arrows, and they're cut by two transversals, okay, that those are being cut proportionally by those parallel lines. Now remember how in our triangles we talked about if we were given like the entire side? That also works here on these parallel lines with proportionality. The entire sides match up as well. All right, so let's go ahead and practice setting these up. So, example 5, finding missing side lengths using parallel proportionality. So here's our unknown. So I have x over, and it matches up with 15. And here's what else I know about x. We have an entire length of 56. So what we need to do is find out what the entire length that would match it on the other side is. That's easy to do. We're going to say 15 plus 9 to give us our entire length. And that gives us a length of 24. Okay, and then to solve it, we simply use cross multiplication. So we have 24x equals 15 times 56. So I'm going to go 15 times 56 gives me 840. And then to solve for x, we divide by 24. And we get our missing side length is 35. Okay, the geometry part of this is the setup. This is the algebra, okay? All right, let's practice another one. Remember, it's all about matching up stuff. So, if this is our unknown, I see who it matches up with across my parallel lines. It matches up with 4. All right, on the same side, we have 10. And who matches up with 10? 5. And then we solve it using cross multiplication. So we're going to say 5x equals 4 times 10. So I get 5x equals 40 divided by 5. We get x equals 8. So our unknown side length was 8. All right, we've got one more goal, therefore one more example, and that is using algebra with our parallel proportionality. This is set up the same way all the rest are. It's all about matching up information. So here's our x value. We have negative 7 plus 3x. We see who it matches up with across our parallel lines. It matches up with 12. The other thing we know on the side with our x is 25. And it matches up with 15. Okay, we're going to solve it using cross multiplication. So we've done the geometry. Now it's time for our algebra. Okay, so we cross multiply. Sorry, my arrow's in the way. So we have 15 times negative 7 plus 3x equals 12 times 25. And we're going to use our distributive property here. And I will be using my calculator. So I've got 15 times negative 7. That gives me a negative 105. And then I've got 15 times 3x. Well, that's 15x. Nope, sorry, 45x. That's what I said in the first place. We're just hearing things. And then we do 12 times 25, which is 300. All right, let's do our variables and our constants. Okay, our only variable we have is 45x. It can stay the same because it doesn't have to go across the line. Our constants, 300. We need to move this negative 105 over here, so we're going to add 105. We end up with 4. Now we need to solve for x, so we divide by 45 to get x by itself. I think my voice is starting to go out. No bueno. All right, we get x equals 9. All right, that's our last example for Unit 6 altogether. I will be dropping a Unit 6 review. Do not forget about doing that to help you with your exam. And do not forget about taking a picture and submitting it of your notes. You can, of course, do the upload with the blank one if you like, and your notes filled in. Please do not use my notes as yours, as in don't submit the PDF copy of my filled in portion of the notes. Like, it should be your handwriting, not mine. If there are any questions, please feel free to message me. And thank you all. Enjoy the rest of your day. Don't forget about your Google form.